Hi, welcome to class. My name is Don LaFont, Professor Don, and this week in Cisco 2, we are covering Module 15, IP static routing. Should be a concept you guys are familiar with since we do touch base with this topic in Cisco 1. I'm going to go ahead and share my screen with you. And if you have any questions about my presentation and you're here with me live, I want you to ask your questions at the break between Module 15 and Module 16. I will record Module 16, our final module, in a separate video. If you are watching this as a recording inside of our NetAcad classroom, please ask your questions in the help discussion forum. And if you're watching this video inside of YouTube, ask your questions down below in the comment section, and I'll do my best to answer those questions. But of course, feel free to answer each other. That's awesome when you do. Okay, so Module 15, IP static routing. This presentation should be about 45 minutes long. We are going to configure IPv4 and IPv6 static routes. We will talk about static routes and describe the command syntax for static routes. We'll configure both IPv4 and IPv6 static routes, and we'll configure IPv4 and IPv6 default static routes, and we'll configure a floating static route to provide a backup connection. We'll close out by configuring IPv4 and IPv static host routes that direct traffic to a specific host. Static routes. So static routes are commonly implemented on a network. This is true even when there is a dynamic routing protocol configured, such as RIP, EIGRP, or OSPF. It's okay to have both static routes and a routing protocol. Static routes can be configured for IPv4 and IPv6. Both protocols support the following types of static routes: standard static routes, default static routes, floating static routes, and summary static routes. Static routes are configured using the IP route and IPv6 route global configuration command. When configuring a static route, the next hop can be identified by an IP address, an exit interface, or both. How the destination is specific creates one of the three following types of static route. When you use the next hop route, only the next hop IP address is specified. When you use the directly connected static route, only the routed exit interface, such as S000, is specified. And when you use fully specified static route, the next hop IP address and the exit interface are both specified as a fully specified address. The IPv4 static routes are configured using the following global configuration command: router, and that here we're in global configuration. IP route, that means IPv4. If this had IPv6 route, it would be IPv6. Network address, the network that you're creating the static route to, the subnet for that network, and either the IP address, which is the next hop IP address, the exit interface, or both, and then distance is what we're going to use to make it a floating or backup route. We'll get to that in a little bit. Either the IP address, exit interface, or the IP address and exit interface parameters must be configured. One or the other, or both. IPv6 is exactly the same. The command is IPv6 route. We have the network portion, IPv6 prefix, and the prefix length, 64 normally. And then the IPv6 address of the next hop, the exit interface, or both, and then the distance used only when configuring a backup or floating route. I'll show that to you. Most of the parameters are identical to the IPv4 version of the command. Now, here is a dual stack network topology, just showing that you have both IPv4 and IPv6 addresses for all of the interfaces, and they have been the interfaces have all been configured. Now, each router has entries only for directly connected networks and associated local addresses. R1 can pick R2, but not R3. So R1, here, let me turn on my laser whip so you can see it a little bit better. R1 can ping R2. It's a directly connected network. But R1 cannot ping R3. That's a distant network, and it's not going to learn that automatically. We can configure, as you'll see as we move forward, we can configure a static route to get to R3. We configure that on R1. Currently, no static routes are configured. If we go to our route, the IP route, if we open up our routing table for IPv4, we'll see we have connected networks. The two, let's see, 172.16.2.0 and 16.3. So we have the 2 and the 3 networks. We can see the 3 network and we can see the 2 network on the R1 routing table, right? We can see that and the actual addresses under the L. We can ping the 2 network and it'll work perfectly fine, but we cannot ping the 3 network. Actually, they don't. 192.168.2.1, 192.168.2. Let's see, where are they pinging here? 192.168.2.1. 192.192. Here it is. Here, 192.168.2.1. We cannot ping this PC from that PC because there's no way for it to get there. It's not in the routing table. Okay, so each router has entries only for directly connected networks and the associated local addresses. R1 can ping R2, but cannot ping R3 LAN. And here we see the same thing when we do IPv6. We can see the 2 network and the 3 network, but when we ping this network, we do not find a route to that network. That is, let's see, that is, it's DB8. That's DB8 Cafe. Oh, ACAD. This is CAFE. 2 different networks. You can ping the directly connected network, but you can't ping the distant network. Let's configure IP static routes. So in a next hop static route, only the next hop IP address is specified. The exit interface is derived from the next hop. For example, 3 next hop IPv4 static routes are configured on R1 using the IP address of the next hop R2. I want you to know it is the same. And the reason why it's the same is to get to the 172.16.1 network, the 192.168.1 and the 192.168.2, the router has to go through the same network. It has to leave here and it has to go to that next hop IP address right there to get to this network, or this network. Those are all distant networks. That you configure 3 static routes on R1 to go here, 1 for this network, 1 for this network, and then 1 for that network. And let me get back to the slide I was working on. And here they are. So you note, and all they're showing you here is that the gateway is the same address for all 3. And they're showing you that S means it's a static route. So we have a static route now to the 1 network, the 172.16.1 network, the 192.168.1, and the 192.168.2 networks. You have static routes to all 3. You still have your 2 directly connected networks. We didn't do anything with those. We've just created a static route to these 3 networks, and it's via the same interface as I just showed you on R1. Remember the next hop. Do the same thing with IPv6 addresses. They're all going to be that next hop address, the same next hop address. And here it is right here, 2001 DB8 ACAD 2::2 2:2, 2:2. To get to these three networks, those three distant networks we saw a moment ago, we have to go through that same router interface on R2. The next hop is the same for all three networks. Once configured, you will have static network addresses for those three networks to get to the one network, to get to the ACAD, CAFE1, and CAFE2. You have to, you're going to go through the same interface, and note S indicates static again in the IPv6 routing table. Now, you can also do it using the next hop address. So when you're configuring to those three distant networks, you can use S001. We can see that address. Now, that is the exit interface. Now, if you go back to this network, it makes sense. You're going to use, when you're trying to tell R1 how to get to a distant network, we either have to say, hey, send this traffic out a specific port, assuming R1 has other ports, send it out a specific port, or we have to say the next hop IP. It doesn't, just remember next hop IP. It's always next hop IP to get to a distant network. So it's either the exit interface, the next hop IP, or both. And in that case, you saw that next hop, the exit interface was 010. And you can see it's to get to these three distant networks, you're exiting the same exit interface. And you can see that we have the three static networks. I don't know why they didn't highlight all three of them, but they didn't. And now instead of having an IP address, it's saying this is the next hop is a serial 010. Same thing is true for IPv6. We're going to use S010 to get to those three distant networks, and you can see them here with the three static addresses that we have entered in the IPv6 routing table. Now, a fully specified static route contains both. So you put the exit interface and you put the next hop IP address. You can see once you enter these three commands, all again using the same exit interface and the next same IP address, then it gives you the three static addresses in the routing table, the next hop IP, and the exit interface. Now, I also want to indicate or to state that the reason why you want a fully specified address is because it cuts down on recursive lookups, and we cover that again here in a couple slides. But ultimately, in order to find a next hop IP, it has to go to the routing table to find out what's connected to that next hop IP address, what exit to exit the router. So that would be our a recursive, meaning it goes back to the routing table. And if you have fully specified, it doesn't need to do that. Now, IPv6 can also be a fully specified static route. Again, you use the exit interface and the IP address, and you can use, in this case, let's see what it's saying here. There's a situation. Oh, then they also add in that there is a situation in IPv6 when a fully specified static route must be used. If you have to use it. In IPv4, it's recommended to use, and it's so you don't have recursive lookups. And in IPv6, it's recommended, same reason you don't have recursive lookups. But if your next IP address is FE80, a local address, then you must also tell what exit interface. Remember your local interfaces, the FE80::2 in this case, this address, if you're using a next hop IP address, which is an internal address, then you must also say the exit interface, because FE80::2 could be in multiple places. So it is required to do fully specified address when you are using a local link address. And here they show that in the routing table. When you go to IPv6 routing table and you and you see here, to get to this network, you have to use the next hop IP address of FE80::2 out your serial interface at 010. And to verify a static route, you can use show IP route, show IPv6 route, ping, and trace route to make sure they work. You can also use show IP route static and show IP route network. You can also go to the running configuration and jump down to the section IP route. If you're going to do IPv6, if you want to verify IPv6 routes, you just add IPv6 instead of IP, and you get the IPv6 version of the command. Now, they're also going to talk about, next, we're going to talk about configuring IP default static routes. So a default route is a static route that matches all packets. A single default route represents any network that is not in the routing table. Routers commonly use default routes that are either configured locally or learned from another router. The default route is used as a gateway of last resort. Second. Default static routes are commonly used when connecting an edge router. Oh, I'm sorry, hang on a second. Are common when using an edge router to a service provider network, or a stub router, a router with only one upstream neighbor. The figure shows default static route. I'm trying to adjust my screen here, so give me just a second, please. All right. And I'll zoom in so you can see that. You can see that just a little bit better. So here, this is a stub network. There's only one network, so all traffic that is not R1 will use default static route. That's not in the routing table. We'll use a default static route of quad zeros. Also, it's an edge router as well, meaning that it connects. Oh, well, this is really the edge router. R2 is the edge router, unless they're considering R2 being your ISP, but normally they put ISP here. So this is your edge router, and if it doesn't know the path, everything is going to go out its exit interface to the ISP. So it would have a default static route as well. Now, the IPv4 default static route is quad zeros. Command syntax for an IPv4 default static route is similar to any other IPv4 static route, except the network address is all zeros, indicating all. And the subnet mask is also all zeros. When you have a default static route of all zeros, it means any route that did not match another route in the routing table, send this way. Right? If you don't have a default static route, if it doesn't match a route in the routing table, it will just be dropped. So this is important to have, and it will be located at the bottom of your routing table, indicating if it doesn't pick up a route as it moves through the routing table, all of the routes that don't match one of the above will be sent out the default static route. The basic command syntax is IP route, all quad zeros, and then again, as we mentioned earlier, either the next hop IP, the exit interface, or both. Works exactly the same way. Now, if you remember how to break down an IPv6 address, :/0 again is all zeros. You can in this case you can eliminate all zeros on this side with the : and then 0 for the network and the prefix, and then again the next hop IP or the exit interface or both, and that is our default static route to catch all traffic that does not match something above in the routing table. They give you an example here. So this would be the next hop IP address, the default static route, and again, next hop address, default static route. To verify a default static route, you go to your routing table, and in IPv4, you're looking for S with an asterisk. See the asterisk right there? That indicates that it is a candidate to be the default route. It's probably your gateway of last resort. IPv6, it'll just have an S. It will not have an asterisk. It will just be an S. You're looking for : 0. That is all zeros, and that is your default static route in IPv6 routing table. Configuring a floating static route. Another type of static route is a floating static route. Floating static routes are static routes that are used to provide a backup path to a primary static or dynamic route. The floating static route is only used when the primary route is not available. To accomplish this, the floating static route is configured with a higher administrative distance than the primary route. The administrative distance represents the trustworthiness of the route. If multiple paths to a destination exist, the router will choose the path with the lowest administrative distance. By default, static routes have an administrative distance of 1, making them preferable to all routes learned from dynamic routing protocol. Only 0, which is a directly connected route, is a lower administrative distance. So the administrative distance of a static route can be increased to make the router less desirable. Anything, in this case, higher than a 1. So if you make it a 5, for example, the 5 will be lower than EIGRP, OSPF. EIGRP is 90, OSPF is 110. RIP is higher than that. So a 5 would be used if the static route, the first route you put in there, fails. In this case, you can see we configure a default static route here, IP route, all quad 0, and then this is the next hop IP address. As a backup, we're going to go to a different router, a different network IP address, and we're going to add the 5. The 5 is a higher administrative distance than the default 1, which is a static route. So the 5 becomes the backup. I want you to note, though, when you go to the routing table, your IPv4 routing table, it will not show your backup route. The only way you're going to see that floating backup route is by disabling your primary route. Remember, the routing table only shows the best route to or for a network, to a distant network. Again, the IPv6, here we can see the static route is : 0. Even though we put a backup here with a 5 being the backup or floating route, you are not going to see it in your IPv6 routing table. You're only going to see the primary. And then they show you here. They say we're going to go ahead and break it, by bringing down one of the networks. Let's see if R2. Let's see. So what happens if R2 fails? This guy fails out here. To simulate this, R2 shuts down both of its serial interfaces. These two interfaces are shut down. And then you go back to the R1's routing table, and you can see now. Note that we're going to that network. We're getting there. The default static route. We're getting there through : 10 : 2, and this is the 10 network. IPv6. They don't actually. Do they have it here? They don't actually have the IPv6 address there, but here we can see the IPv4. You can see it's 10.10.2, 10.10. That's the 2 would be the next hop, and they don't have the IPv6, but we can assume it's the 10 network, and it would be here. Configuring static host routes. So sometimes you want to create a route to one individual address. For example, you might have a server that you want to be able to have a host route in the routing table statically configured for. So a host route is an IPv4 address with the 32-bit mask, or an IPv6 address with the 128-bit mask. The following shows 3 ways a host route can be added to the routing table. It can be automatically installed when an IP address is configured on the router. It can be configured as a static host route, and it can, the host, so that you know what the IP address is, and the host route automatically can be obtained through other methods discussed later in the course. Now, automatically install host routes. Cisco IOS automatically installs a host route, also known as a local host route, when an interface address is configured on the router. The host route allows for a more efficient process for packets that are directed to a directed to a router itself, rather than the packet forwarding. So this is in addition to the connected route designated with the C. So C is the network. L are these local routes that are automatically configured. When you bring up a network, you get the C and the L. You can also create a static host route. The only difference between creating a static route, as we did previously, is you use a /32 or a /128 to that address. So here we have a server, and it's 209.165.200.238/26, and we also have 2:2:238. So it's the 200 network and the 2 network. And notice when we go to our host route that we're creating, it's IP route. Here's that 238, and notice the subnet is all ones. It's 255.255.255.255 or /64, and we have then we have the next hop address. And so that's saying to get to this one address, we're going to go to that interface. IPv6 route to get to we're going to use 128 here. So to get to this address, 238 2:238/128. Again, one address. To get to this one host address, like a server, you're going to go to this next hop IP address, and then you exit out, and then you can go to the routing table and you can see static route to a specific host, and you can see the static to in the IPv6 routing table. You can see that one address. See /128 here, indicating it's an IPv6 static route. Static host route. Now, configuring an IPv6 static host route with a local link next hop, that basically indicates that you just have to use the exit interface in addition to using the next hop IP address. So IPv6, you can see here. To get, we got rid of that's what the no IPv6 route is. We removed our previous entry that we entered on the last slide, and we're going to have IPv6 route, and then to get to this one host address, we're going to use the exit interface of 010, but we're using a local link address of FE80::2. You have to have both if you're using local link addresses, because otherwise that FE80 could be in multiple networks and it won't work. It'll actually give you an error message indicating that you have to do a fully specified address if you don't insert one. And here you can see to get to this one host address, you have to go exit interface and next hop IP and exit interface. You're going to do a packet tracer to configure IPv4 and IPv6 static and default routes. You're going to do a lab to do the same. And believe it or not, I teased you with the 45-minute precursor. This presentation is over. In only 30 minutes. Fantastic. I love when that happens, and I'm sure you think the same way. All right, so let's go ahead and stop sharing. If you have any questions, a pretty simple content. Matter of fact, there's not that much more than what you learned back in Cisco 1, except it explains a little bit more and it adds the floating route or backup route concept. You won't have any problems with any of these assignments. They're relatively easy to do. If you have any questions about today's presentation, please ask in a moment if you're here with me live. If you are watching as a recording on our NetAcad classroom. In our NetAcad classroom, please ask in the help discussion forums. If you are watching this in YouTube, please ask questions down below. I'll be happy to answer those questions. Feel free to answer each other. Also, please rate and review my presentation on YouTube and follow. I really appreciate it. It helps me out. And you'll get notifications when I post my next presentations. That's it for tonight in this presentation. Thank you for coming to class. My name is Don LaFont, Professor Don, and today, and have fun learning your Cisco content. Thank you so much.